Hello, in this modern OpenGL tutorial, we're going to be looking at model loading. In this video, we're going to be looking at setting up and creating the mesh class. For setting up, there are a few different ways you can do it. If you're on Mac, the easiest way is to use Homebrew. And once you've got Homebrew installed, we've shown you how to do that on the Mac setup videos. Once you've got that, you just do brew, install, Assimp. Assimp is the model loading library that we're going to be using. It's a industry standard, supports a wide array of models from Wavefront OBJ to Collada to a bunch of others. For a full list, check out the GitHub page or their website. And once you do that for me, I will get a warning saying that it's already installed because, well, I've already installed it. So let me just wait and get that particular warning any moment now. Okay, there you go. As you can see, it's saying already installed. For you, I'm guessing it won't say that because you won't have it installed. On Windows, you can even get the pre-compiled libraries, but they don't always work. So what I would say is use CMake, and I'll show you how to use CMake. And once you've actually, first of all, you want to download CMake, and you can get that from just type in CMake into Google, go to cmake.org, let's go to download, and then if you just scroll down, you can download the release candidate, but I would say download the latest version because that's the definitely stable version, or stable as it could be. Download whether it's Windows, Mac, or Linux. This tutorial will be relevant for all of them. I'm not going to do a Windows separate tutorial because once I've shown you how to generate and compile Assimp, you'll be able to link it using the skills that you learned in the setup videos for Windows or for Mac if you do want to do it manually instead of using Homebrew on Mac. So once you've downloaded that, you want to download Assimp as well, and also make sure you've installed CMake. It's just a simple executable, so installing it shouldn't be a problem. So if you go to the Assimp website, go to downloads, and then just go to download page or Sony, and then just download it. So from the GitHub page, once you've done that, you'll get a file like so. It might be a different version, should be fine. Extract it and you'll get something like this. And then what you want to do is go to browse source. So this is the Assimp folder that we've extracted. Go to wherever it is, click open, and then what you want to do is click, you also want to do browse build. So this is where it's going to build our library. So probably not best if you put it on desktop, probably best if you put it within a specific folder because it will generate quite a few files. And then if you just click configure, from here what you want to do is select your particular sort of environment. So for me it would be Xcode because I'm on a Mac. For you, if you're on Windows, you'll have a Visual Studio option. You select the Visual Studio option, you'll generate the appropriate files. Once you have the appropriate files, like I said, you just link it the same way that you've done in the setup video for GLFW, GLEW, SDL, or SFML. If you do have any problems, feel free to ask and we will help. But as I said, the process is essentially the same after you've compiled it, and it is good if you can sort of do it on your own, but we're always here to help. So let me just quit that. So essentially you've done the setup process now. So once you've done that, we're ready to create the mesh class. We're not going to be including Assimp in this tutorial. The mesh class simply will store data that we've already covered in previous videos, such as texture coordinates, vertices, normals, all of that good stuff in a nice container. And then what we're going to do in the next video is create a model object, which will essentially be a container for several mesh objects. And the model object will be using Assimp. So if we just go to our project, you just right click, new file. Then you want to go to a CPP file. So if we go to C++, next, actually no, my bad. We don't want a CPP file. What we want is a header file because the bit of code that's going to be there, we're just going to whack in the header. So if we go to next, and if I change this to mesh.h, targets OpenGL, so just save it where you got your main CPP, your camera, and your shader headers. create. We got this cool file right here. And what we'll do is we'll get rid of all of that. And one thing I've noticed is what I don't have is set to recording mode. So the text is going to be bigger now. So if we go into here, just put hash pragma once. That's all good. And I also forgot, if you go to your main.cpp, a lot of this code we can just get rid of now because we are no longer using, well, the old Lightning code, the old object code to create cubes. You can mix and match, and I highly recommend that you do that because that's a great way of learning. So if we go to, we've got our GLEW initialize, we keep scrolling down. We pretty much want to get rid of all of this. So if we just keep going, essentially you probably could get away with going back to the setup videos and just getting the code from there, because we don't need any of this, any of the cube position. We can get rid of all of this, the vertex array object, the vertex buffer object, get rid of all of this, the lights, still going. Get rid of soil as well, because we'll be using soil in our mesh and model classes. And I believe I've gone a little too far now. Okie dokie, I possibly have gone a little too far. I'm just wondering, have I selected where I put GL viewport? Because we still need that bad boy code. Let me scroll up. GL viewport, no, that's all okay. So GL viewport's there. So we don't need this anymore. We'll leave this code because this was used when we was using alpha images. This shouldn't interfere with anything. And in here, I'm going to get rid of this old code. And if we scroll down, we're going to get rid of essentially all of this. Keep going. Like I said, essentially anything that isn't for setup purposes, you're going to be getting rid of. So if I just keep going down, I wish the scrolling was faster, but I know we're almost there now. Keep going, and it should be after this loop, or a bit more. And that should be it. So we also need to get rid of this because we're no longer deleting our vertex arrays and buffers. And now I'm going to leave this comment there because that's where you would put it. I'm just going to make sure all the appropriate code is still in there. Looks all good. So I'm going to do a quick run just to make sure I haven't deleted any code that I shouldn't have done or messed anything up. That looks a-okay. So that's all good. So if I go to the mesh header now, and now let's close all of this, and now we can actually start coding. So what we're going to do is hash include string, hash include fstream, hash include ssstream, the bunch of streams that are being included, hash include iostream, hash include vector. And now we're going to do hash include gl /glew.h, then do hash include glm /glm.hpp. So this has the assumption that you've obviously set up GLEW. I'm guessing you have if you're in this video, and that you've set up GLM. We got a separate video covering that. So let's continue. Hash include glm /gtc /matrix underscore transform.hpp. I'm going to build it, mate. Yep, building is also good. Use the namespace std. We're going to be using that quite a bit. First of all, I'm going to create a struct for vertex, so vertex, and for the field it's going to have the position, the normal, and the texture coordinates, which are going to be vectors. So we're going to have glm colon colon vec3 position. Now glm colon colon vec3 normal glm colon colon. This is going to be a vector too, because this is the texture coordinates of an image, and you don't have 3D in an image, it's just x, y, and z. I mean just x and y coordinates. Cool text coords. And what I'm going to do, I'm going to add a bunch of empty lines here, so it's just easier to scroll up and down. Struct. One thing I noticed, although I don't know if I did this, when I actually do lecturing at a university, and I've been teaching first year students C++ programming, and what I've noticed is they put a bunch of like space like so, but it'll be, for example, you'll be in the main function on your on your main.cpp or whatever it's called, and it just sort of looks odd. Obviously, because you know they're new to programming for the most part, so it doesn't look quite structured. So, but it's trying to you obviously have to try and get into the head like early on that there's certain things that you should do, certain things you shouldn't do. Before I just mentioned that because I was talking about going up and down with multiple just empty lines. So now you want to do glu int for id, string type, AI string path. A lot of this will sort of become obvious what it is for, and we'll explain it as we go along. So just bear with us. I'm going to create a class for mesh. So this is the actual class that would be called, and it's going to have a bunch of public variables and methods. Got to spell public correctly first. Okay, so this is going to be the mesh data. So it's going to be vector, vertex, vertices, basic stuff. So basically, you can make up the corners of some sort of object. Vector of glu int indices, vector texture textures, and now we're going to do the constructor. So this is going to be mesh, and this is going to take a bunch of parameters. So the first one is going to be vector vertex vertices, and this will be assigned to this particular variable right here, and then we'll have the indices and the textures. Actually, you know what, it'll be just quicker if we copy and paste these. So copy and paste that there, copy and paste this one here after a comma, and now what we're going to do is do this vertices equals vertices, basic stuff. We'll do the same for indices and the same for texture. So I'm just going to simply copy and paste this here, here. Do the same for textures. So we'll just pass in the data for the vertices, the indices, textures, and assigning it to the meshes variables so it knows what data it needs. So now that we have all basically the required data, we can actually set the vertex buffers and the attribute pointers. So to do that, you do this setup mesh. We haven't created this method yet. We'll be creating it very, very soon. So before we actually create that, we're going to do the draw method. So the draw method is public as well. So void draw, and it's going to be shader, and what we're going to do is glu int diffuse equals 1. So the number of diffuses is 1. we're going to do the same for specular. So specular equals 1, and we're going to do a for loop, and this is going to be GLU int I equals 0 while I is less than this underscore textures dot size. So it's looping through the textures, and as usual I plus plus. And in the for loop, what we're going to do is set the active texture. So GL active texture, and in here it's going to be GL underscore texture 0 plus I. So we're going to activate the proper texture unit before binding anything. And now what we need to do is retrieve the texture number, aka the n in diffuse texture n. So we do string stream. If you haven't done string stream in C++, I recommend do a bit of googling and check that out. Very simple stuff. So string number, string name equals this, textures I dot type, scroll down a bit, and now what we want to do is check if the name is a texture diffuse or texture specular, aka is it a diffuse or a specular texture. So we're going to do if name, actually I would prefer Yoda condition, so texture underscore diffuse equals name ss. So we're going to input into the string stream, so that's going to be diffuse number plus plus. So we put it into the string stream and then we increment it, and now we're going to do else if, and now we're going to check if it's a specular texture. So if name, not Bane, name, Batman's nemesis is not here, I mean texture underscore specular equals name ss less than specular number plus plus. Again, we do the same for the diffuse, so it just increases the number of specular sort of objects that we're using, or specular textures that we're using, so we know how many, well, specular or diffuse textures we are using. Very simple stuff. And now the number is going to be equals to the string stream string, so we're just going to get the string from the string stream. And now we just need to set the sampler to the correct texture unit, and for that you do GL uniform 1i. So it's going to have one integers, and it's going to be GL get uniform location, and in here it's going to be shader dot program, and this is going to be name plus number dot c underscore string, and this is going to take the iterator. So we got that all sorted, and now we're just going to finally bind the texture. So GL, let me scroll down a bit, bind texture, GL underscore texture underscore 2D. Again, this is all stuff that we've done in previous videos, whether it's the texture stuff, whether it's to gain the uniform location. We're just all bunching it together into a nice class for our object that we'll be loading in the next video. So textures I dot id, and now we have done the draw class. What we need to do is just, actually No, I mean we've done the for loop within the draw class. Still got some more code left. Now we need to set each mesh's shininess property to a default value, so you can, well, default values are always good in case it doesn't have some sort of default value, and it's to prevent it from messing up. So GL uniform 1F, and this is going to be GL get uniform location, and for this it's going to be shader dot program, and I think you can guess where we're going with this. It's going to be material dot shininess 16.0f, so reasonable default value. And now we're going to draw the mesh, so it's GL bind vertex array this vertex array object, no varo, VAO, and we haven't created the vertex array object variable. We'll create that in the private set of variables and methods. Now do GL draw elements. Let me scroll up slightly, scroll down so you can see more of it. Not more of it, but I think if it's centered it just looks easier to read. Maybe that's just me. Let me know, because if you let me know what's best for you guys, I will improve it that way. GL underscore triangles, and this is going to be this indices dot size GL underscore unsigned, not sun-signed, unsigned underscore int comma 0. And now we're just gonna unbind the vertex array, so you do GL bind vertex array to 0, and now we just need to set everything back to its default values. Once we've all done this configuration, it's just good practice. So for GL u int I equals 0, I less than this textures dot size, and now you're just going to do I plus plus. Now GL active texture, and for this you just put GL underscore texture 0 plus I, and now you need to just bind the texture. So GL bind texture, I'm going to bind it to 0. So GL underscore texture underscore 2D is 0. And now we have actually done the draw method, and that's everything in the public section of the mesh class. So I'm going to do private now, and in the private we got a few variables. So it's GL u int, and this is going to be vertex array object, the vertex buffer object, and the element buffer object. We've explained what all of this does in previous videos, so if you're not too sure what any of this does, feel free to go back, check out those videos. Once you understand the concepts, come back and you should be all good. So now we just need to initialize all of the buffer objects and arrays. So this is going to be the void setup mesh, mesh that we called up here. Where do we call it? We called it right here in the constructor. So this isn't something that the developer really would be calling manually. It's once whatever is using the mesh class as an object has constructed it, it will then call the setup mesh method. So first of all, we need to create the buffers and arrays. So for that, we're going to do GL gen vertex arrays, and this is just going to be 1 comma ampersand this VAO. And now we need to do the same for vertex buffer object and the element buffer object. But for this, because it's a buffer and not a vertex array, you need to do GL gen buffers 1, ampersand this VBO GL gen buffers 1, ampersand this EBO, and now we just do GL bind vertex array, and it's going to be this vertex array object. Now we're going to load the data into the vertex buffer, so we're going to do GL bind buffer, and it's going to take the GL underscore array underscore buffer, and what we're going to bind is the vertex buffer object, so VBO. And now what we need to do is do the buffer data. So this is just, gain the size of the vertices. Again, all simple stuff that we've done before when you compare it with our cube that we've been doing for, I think, like so many videos. I think over 10 videos we've just been messing around with a cube in some form or another. So for that, you just do GL buffer data, and in here it takes GL underscore array underscore buffer this vertices dot size times by size of, and it's going to be vertex ampersand this. So we're just getting the first vertices, and because obviously we're in the reference to it, and now we need to just do GL underscore static underscore draw, not draw, just draw. And now we need to bind the buffer for the element buffer object. So what we'll do is, could just copy and paste this to change what I need to do. So copy that and change this to element underscore array buffer, change this to EBO, and now what we need to do is do the same for the buffer data as well. So I'm going to copy and paste this, and let's group this. And for the buffer data, you need to change this to element array buffer, and this is still going to be this indices dot size indices dot size times by size of. It's no longer the vertex, it needs to be GLU int, because that's what it is, that's the data type. And now for this indices 0 g underscore static draw, that looks all good to me. I'm just going to have a, because we copied and pasted it, so I want to make sure it is all right. Looks all good. So now we can move on to setting the vertex attribute pointers. The first one is the vertex positions. So for this, I'm just going to put vertex first comment I've put in the code that's available on GitHub for this tutorial and all the other tutorials in this series, which there'll be a link in the description for. It is commented, so if you do need a bit more help, you can check that out. And now we're going to just do GL, let's do capital, enable vertex attrib array, and this is me set to 0. And now we're going to do GL vertex attrib array, attribute pointer. And now this is Again, we've done all of this before when we're doing the cube like a billion times. So 0, 3, GL underscore float, GL underscore false, size of vertex, and that should be capital V because it is of the particular type of data that it is, not some variable. And now we're going to do GL void times by zero, and now what was I going to do? It's the vertex normals now, so we're going to do vertex normals, and now for this we can actually copy and paste a lot of this code, so we'll just change that to 1, and we can copy the vertex attribute pointer as well. We'll just change what we need to change to speed up the process. So change this to a 1, this remains as a 3, GL float is fine, GL false is fine, the size of we're getting the vertex. For the GL void we are now doing an offset, so offset of the vertex and normal. And that's it for the vertex normal. Now we need to do the vertex texture coordinate. So vertex texture coordinates. I think I spelled it correctly. It's only a comment. So now let's copy and paste this. And copy and paste this one. I think you probably could guess what's going to go in here. Most of this is staying the same. For the offset, it's vertex, but it's because it's no longer normals. It's the texture coordinates. And now we have one more line of code, and that's GL bind vertex array. And basically we're unbinding it, so we set this to 0. And I'm just going to build it, make sure it's all good. It's building correctly. So let's just make sure it's all correct I'm just going to put some bogus sort of stuff here. Actually, I can't really do that until I include the file. So if I were to do hash include mesh.h, build it. Okay, we've got build failed, so let's have a look at what it's failing at. Okay, so it is failing at AI string. So why is that moaning? Let's have a look. So unknown type AI string. So let me just have a look at why that would be moaning. Make sure everything's included. So we got the vector, we got the IO stream, we got the S stream, we got the F stream, we got string. Looks all good to me. And oh, for a semicolon there, so let's rebuild that. So now it's just the unknown type name. Unknown type name. You know what? I'm going to leave it for this video. And the reason for that is because in the next video, a lot of the code that we're going to be doing is going to be using this code. And just it will get fixed, I assure you, in the next video, because like I said, a lot of the code will be linked together and we'll make sure it's all good. So the mesh class is all created now, so just ignore this error, and when we get into the next video you'll be using this code and we'll make sure it all works. So this has been it for the mesh class, and setting up Assimp. If you have any questions, feel free to post them on our education platform, sonarlearning.co.uk. There'll be a link in the description. Plus, there'll be links in the description to learn OpenGL.com and Open.gl, which are the websites that we have based these tutorials on. Feel free to check them out. They're really good tutorials and websites. They're in written form, so check out these videos and then look at those links because they provide stuff in more depth. They explain it more. They have images that accompany it. It's just overall a great experience to enhance your OpenGL learning. And there'll be a link in the description for the GitHub page, which I mentioned. If you like the video, please give it a thumbs up, hit that subscribe button and leave us a comment. And as usual, thank you for watching and I hope you have a great day.